So in the last video, we looked at this problem where we've got water flowing out of the bottom of a tank at a rate proportional to the cube root of the volume. We use that to find the general solution to the differential equation, which is h is equal to p minus qt to the power 3/2, where p and q are just constants. We're now going to use that expression to find some particular solutions to that differential equation and then use it to solve a subsequent problem at the end. So we're given that initially the height of the water is 27 metres, 10 minutes later the height is 8 metres, find the values of the constants p and q. So if we've got initially, that means that our time value is equal to 0, and that at t equals 0, we have our height h, which is 27. So with those, we can substitute those into our general solution. So 27 is equal to, the t is 0, so this minus qt, as q is just a constant, goes to 0. So you have p to the power of 3/2. So rearranging that then, p is equal to 27, flipping the power, to 2/3. The cube root of 27 is 3, and 3 squared is 9, so therefore p is equal to 9. So at this stage, if we substitute in, h is equal to 9 minus qt to the power of 3/2. We then need to use the next part of the statement, which says 10 minutes later, the height is 8 metres. So now we've got a t is equal to 10, and the height is equal to 8. Again, we can substitute them into this expression here. So our height is 8. So 8 is equal to 9 minus our t value is 10. So 9 minus 10 q to the power of 3/2. So we can say 9 minus 10 q is equal to 8, flipping the power, to the power of 2/3. The cube root of 8 is 2, and 2 squared is equal to 4. So therefore 10q, 9 minus 4 is 5, and q is therefore equal to 1/2. So with both of those, we can state our particular solutions. H is equal to 9 minus 1/2 t to the power of 3/2. So that is our particular solution to this problem. So part D says, find the time in minutes when the water is at a depth of 1 metre. Well, we're going to use our solutions, which we've just found for P and Q, and we're going to use this when our height h is equal to 1, and use that to find a value for t. So if h is equal to 1, 1 is equal to 9 minus 1/2 t, the power of 3/2. Rearranging the powers, well, 1 to the power of 2/3 is still just 1. So 9 minus 1/2 t is still just equal to 1. So 1/2 t is equal to 9 minus 1, which is 8. So t, 2 times 8, 16. And specifically our time is in minutes. So it's a time of 16 minutes. And that's the time when the water is at a depth of 1 metre. So we've used our general solution to find particular solutions for the information we've been given, and then we've used that to find the time for the height of the water at 1 metre.